Hi, Matthew.
Hey, Emilia, good afternoon. What would you like to work on today?
I think I sent, if I remember, the PowerPoint, just like the review PowerPoint that has like all the topics that'll be on the test.
All right, let me see if I can find it here. I don't see. If you send it by email, the last email I have from you is from.
I attached it to the.
Okay, I can find it. Yeah, let me go find it that way. Need just a moment to get that information. Okay, of course it's not there. All right, let me find it in another place. All right, there. I'm sorry for the delay. I'm trying to find it here. I may just have you send it by email. There's the other one.
It was just called, let me see. It's attached to the booking for, oh, maybe that's it. It's attached to the booking for Wednesday, tomorrow.
All right, there it is. Okay, let me copy. All right, so got it now, and hopefully it'll just download. Files being downloaded. Hooray. Okay, so I'm looking that over here. So you got some 11 multiple choice, 2 free response. Most of it is non-calculator, few calculator. Not seeing any problems here, so I guess I got to make some up for you. There's also a review assignment. Have you done that already?
I did that.
Great. Any questions on that?
No, I already turned that into him today, so.
Okay, so let's we'll just start with this in order here. I'm gonna start with slide 3. Let me share my screen and we'll get started. The first thing is being able to do an LRAM or RRAM, and let's do it. Let's do it this way. So let's say f of x equals the square root of x. Let's go 2 square root of x from 1 to 9, and we want to do this for n equals 4. Okay, so they're very similar. The first thing is to find delta x. So delta x is b minus a over n. That's 9 minus 1 over 4, which is 2. Okay, and then what I recommend is starting with a and going out like delta x. That's 3, 5, 7, and then 9. And if I do this again, I'll just write them again, 1, 3, 5, 7, and 9. So LRAM will use these, and RRAM will use these 4 over here on the right.
Okay.
All right, so the graph of 2 square root of x, do you think you'll be asked to graph it?
I don't know. He had us do one like that on the quiz, you remember? So
yeah. Okay, let's just go with it for a moment. So I would make a table. X, y equals 2 square root of x. So you got to pick points that are nice, and you only have a couple of them here. So 2 times the square root of 1 is 2. Square root of 4 is 2 times 2 is 4, and then 2 squared root of 9 is 6. So you have these points here on your graph, and so you're 0, 0, 1, 2, 4, 4, and then 1, 2, 3, 4, 5, 6. So we got something that looks like this. Okay, and then let me copy it because we're going to do 2 graphs here. So I have it for the next one. Do you want to do RRAM or LRAM first for the graph? Like what do you do?
Lram.
Okay. So LRAM, you start on the left and wherever it hits the curve, and it hits right there. So there's actually no area to that one.
Okay.
And but the delta x is 2. So make sure you go out 2, because I was about to only go out 1. Then you go up and hit it in the next point, and you draw your rectangle in to the right.
So Lram is the one that's under the curve?
Not always. In this case,
Okay.
it is. Yeah. We could do one like 1 over x where it wouldn't be.
That would be okay. I see.
All right. So then, so that's at 4. 4 hits it there. No, I guess that just worked out. Okay. So what am I doing here? 6. Did I miss something here? Okay. Yeah. So 6, and then you hit 6. I'm sorry. I'm messing up here. I apologize. It starts at 1, not at any of these values. So I wasn't even paying attention to the problem I made. So the problem I made says starting at 1, not at 0. So we actually don't even need this part of the curve. So there's it at 1. So from 1 to 3. And then 3, you go up and hit it wherever that is, and you go right. And then there's 5, and then 5, you go up and hit it, and that's 7. And you stop when you have 4 rectangles. It is possible that your rectangles won't have like there is a possibility of like it won't have any height, but this is for LRAM. This is your LRAM graph.
Okay.
So RRAM, you're starting over here at 9.
So you go like backwards?
Yeah. So you hit it, boom. This time it's an overestimate. Just happens to be that way. Okay. And then you hit it again, right? So you hit it there at 7. So you hit it right up there, and you go to the left. Then you hit it there.
Why are you going to 5? Aren't you supposed to go? Oh, I see. You're doing that. What was that chart on the top left?
So
The
I was
9?
just trying to graph it, and I needed some nice points,
Oh, I see. Okay.
but not all of them are useful.
I see. So now you're going to 3.
Yeah.
Okay.
All right. So we scroll down and we'll go to 3, but we go up to 5. We hit it there at 5. Go left to 3. Boom. Hit it. Boom.
Okay.
All
And
right.
then you just do the areas of those 4 and then add them up, right?
Yeah, but we're going to go back here to the actual calculation to do it, because we got to do it right. But you got to be able to draw it. So anything you want me to cover again on this?
No, that makes sense.
Okay, so LRAM is your delta x. Your delta x is 2 times f of 0. Well, I'm sorry, f of 1. The reason it's f of 1 is because I said it was going to go from 1 to 9 plus f of 3 plus f of 5 plus f of 7. So each of these numbers increases by delta x.
Right. Okay.
Okay, so your f of x is 2 square root of x. So the calculation is 2 times the square root of 1 plus 2 times the square root of 3 plus 2 times the square root of 5. So I'm just putting these numbers 1, 3, 5, and 7 into here, plus 2 square root of 7.
Okay.
And that's your final answer. You can't do anything more with this, but if you had a calculator, you could maybe do something.
So why don't you just do the areas of the 4?
Well, you'd have to estimate them, and you'd have to graph this really precisely to know that.
Oh, I see.
This is exact, and everything else is an estimate.
Okay, gotcha.
All right, so RRAM is very much related. You're going to see like a lot of duplication. So RRAM is 2 times, because again, it's delta x. But this time, you don't start at the first position. You actually start at the second one, f of 3 plus f of 5 plus f of 7 plus f of 9.
So it's 2 times, wait, is it the same?
Yeah, it's the same function, 2
Same
squared 3.
with 2 root 9. I see.
Yeah, plus 2 square root 7 plus 2 square root 9
Okay.
times 2.
All right.
All right, so then the next thing on this list, it says like, what does area under a curve represent? And that's kind of like it's case specific. Let me snip that in, because it could be a lot of things, but let me snip this question in. All right, so what does area under a curve represent? And like there's a lot of things here, like if this is f of x and we're going from a to b, like that the integral f of x dx from a to b is the area under a curve.
Right.
That's one. But if like, let's say I gave you a table. So let's say we were measuring and like we've already done this. Let's do a different example. Let's say it was kilograms per second of that's not true. Let's do liters per minute of a pool draining out. So like, let's say the rate is 100, and then it's 90, and then it's 75, and then it's I don't know, 40, 10, like that. And this is in minutes. So let's say minutes. Let's say after 2 minutes, 8 minutes, 14 minutes, 20 minutes, and 24 minutes.
Okay.
All right. So now we could ask for the area under the curve, and what is its meaning. So if we were to graph this, this axis is time, and this is liters per minute. So the area under the curve is liters per minute times minutes, which is just liters. So that's why I said it depends on what you're looking at. It really depends on this quantity here. It depends on the rate, basically. So I'm not sure what the instructor had intended there.
Okay.
But you can certainly do this. So let's take this table here, and let's say we wanted to do an Lram and an Rram.
Okay.
So an Lram, you need delta x, which is the x variable in this case.
The minutes.
Yes, sometimes it's out of order. So and that's the difference between these.
6.
So it's 6 times.
Wait, no, but that one's 20 to 24.
Oops, it's supposed to be 26.
Okay.
All right, so 6 times, and then use the left values. So 100 plus 90.
Right, up to 40.
Yeah, because I should have told you this is n equals 4. Okay, and then Rram.
6 times 90 plus 75 plus 40 plus 10.
Yes.
Okay, so in that case, you just use the value size.
Yes, no calculations, no like evaluating functions.
Right.
Okay, so that closes out slide 3.
Okay.
Slide 4, let me just snip this in. Okay, slide 4, it says Riemann sums, which is kind of what we just did. Area under a curve is a definite integral. Integrating discontinuous functions. Okay, so that one, I guess that could be something your instructor might do. And that would be like a piecewise function. And then this is your calculator.
Wait, the Riemann sums are the ones are like.
Yeah, the LRAM, RRAM, MRAM.
Oh, okay.
This area under the curve is a definite integral. It's just writing the integral from a to b f of t dt, something like that. But I'm not sure like what that refers to specifically.
Wait, what would the problem be like for that? Like,
so like it could be that the instructor says what, or let's do this. It's probably like a which of the following include the area under the curve, and the x-axis. Okay, so I'll try to give you ones that are wrong here for the moment. So let's say it's the integral from -2 to 3 4 minus x squared dx. So the reason this is wrong is if you were to graph 4 minus x squared, it goes like this, and then it goes like this. But then at 3, you get some area underneath. And it said just the x-axis.
oh, okay.
This is a total guess. But it would be like what is correct? The correct would be the integral from -2 to 2, 4 minus x squared dx.
Okay, I see.
What else could your instructor ask here? Could be they could get, okay, so I think maybe here's another possibility. They give you something like this. They say here's this A, B, C, and then D, and this is f of t, and they want this written such that it's only positive areas.
Okay, so B
So
to C.
Yeah, B to C, f of t dt, that's great. That's the easy one.
Mhm.
But what do we do from A to B? There's a couple of options here. Like you can add,
Flip them.
right, you can go from B to A, f
Yeah.
of t dt. I think I would rather see this as an instructor, where you just negate it.
Okay. So then the same thing for C to D too?
Yes. So you'd have another minus integral C to D f of t dt.
Okay.
But another thing like that the instructor could do is that they could say, oh, this is G of t, and you have to change your notation, and this is H of t maybe. So
well, in that case, you just change the F.
yeah, that's
okay.
H and H. I'm not sure, like what.
Yeah.
Getting into the mind of an instructor, I don't know. So that's as far as I would take it for this.
Okay.
I think we should talk about discontinuous functions, meaning piecewise functions.
All right.
Is that okay?
Yeah.
All right. So I'm going to give you a piecewise function. I'm going to say it's f of x equals minus x from, let's go -4 less than or equal to x less than or equal to 0. And then it's x squared from 0 less than or equal to x less than or equal to 2. And you want to find the area under the curve here.
Okay.
So I'm going to graph it just to think that would help, but minus x looks like this. And then x squared looks like this. So you're essentially finding these regions. So like, how would you write region A?
How do you know that it? Oh, because it's up to -4. I see.
So do you see that this would be negative?
1/2.
Well, no, you got to write it as an integral. Yes, you can do it that way, but it's the integral from -4 to 0 minus x dx.
Yeah.
plus
0 to 2
right
x squared dx.
Right. Now you have your choice, like you're just about to tell me. Like this one, you can use areas or antiderivatives. This one, though, you have to use antiderivatives or your calculator, I suppose, if you had it.
Okay, so the first one is just 1/2 -4, and it goes up to 1, 2, 3, 4. So -8.
The area is above the x-axis, so it can't be negative.
Oh, +8.
Yes, and that's why it's maybe better to do it this way. It's negative x squared over 2 from -4 to 0.
And you just evaluate.
And then you put in -0 squared over 2 minus 4 squared over 2. Lots of minuses, but they all sort of work out like this is 0. These make +8. So it's like you said, it's 8, but this is the direction you're going in this class.
Okay, and then the other one is x cubed over 3, right?
Yes, yes. So let's go back up and do that one.
2 cubed over 3.
0 to 2.
So that's 2 times 2 is 4, 4 times 8 over 8/3, or 8 plus 8/3, right?
Yes, so it's 8/3 plus the 8 from down here.
And then you do common denominator.
Yeah.
So then it's like 8 times 3 is what, 24?
24, yeah.
Over 3 plus 8 over 3. So that's 32/3.
Yes.
Okay.
Right. So that's an example of discontinuous functions. Although I'm sorry, that actually wasn't discontinuous, but I wouldn't have had to change it much. It would have been kind of the same. Like discontinuous just means like instead of them connecting here, like one might have been a jump.
Like, what would you do differently in the?
Yeah. So let me grab this and I'll just change it slightly so you can see. You actually don't do anything different.
Oh, okay.
But let's say it was x squared plus 1. So all of this on the right, it goes up 1. So see how it's now discontinuous. The graphs don't touch here in the middle.
Yeah.
So the only thing that changes is just this part over here on the right.
You just, oh, I see. You have to write it up 1. Okay.
Yeah.
Okay.
Do you want us to do another example like this? Maybe.
Yeah, maybe one more.
Okay. So let's say it's f of x equals minus x plus 2. Let's go minus 2 less than x less than 1. And then we'll go x plus 3 from 1 to 3.
Okay. So do a graph. So then it's up 3. Up 1 over 1. 2. Oh, -2. Oops. And then, oh wait, okay, wait. Start.
So you like the shortcut is you can actually just write the bounds here. Like you don't have to actually graph it.
Oh, okay. I feel like that would be easier for me if I just don't.
But I don't like, I guess I'm not sure if that considers all cases, so you'd have to be careful.
Well, I was just confused because why do you start like if it's oh, it's negative x plus 2. That's
Yeah.
why.
Yeah.
Okay, wait. So then it's x squared negative x squared over 2 plus 2x at 1 and negative 2. So then that's negative 1 or negative 1 squared over 2. Negative 2 squared. So then that's 1 over 2 plus 2 or negative 4 over 2. So that's plus 2 minus is it is the left side 17 halves? Oh
Yes.
wait,
Well, no, I'm sorry, it's 15 halves because it's 7.5. Right? These make 8. 16 over 2.
isn't it when you put in negative, because isn't it negative 1 squared? Like for the very first one?
Yeah, but you square before you negate.
Oh yeah, that's why. Okay. So then it's negative. So then it's minus 1 half. Okay, so 15 halves.
Yes. And then this one on the right. Okay. Same deal. X squared over 2 plus 3x from 1 to 3.
Okay, so then it's 3 squared over 2 plus 3 times 3 plus 1 over 2 plus 3. So that's 9 halves plus 9 plus 1 half plus 3. Oh wait, it's minus.
It's okay to take another step to write out the distribution of signs. It probably will help. That's 20 over 2. That makes 35 over 2.
Halves plus, let me just make sure I get the same thing. 30. Oh. Wait, so 9 halves plus 9 minus. Oh, I see. Okay.
Yeah,
Okay.
you want to try always pick the ones that are easy to combine as much as you can.
All right. What isn't it? I'm not getting 20 over 2 on the right side though. Because isn't it? Okay, so you do 9 halves plus
And 1 half. That's 8 halves.
Yeah.
It's minus though. It's minus. So it's 8 halves. That's 4. and then 9 minus a 3, because it's positive in here.
X. Oh, I see. I just kept it as 8/2. I could have put it as 4.
Yeah,
Okay.
and then just changing it so that you can combine it with the number on the left.
Gotcha. Okay.
All right, so I feel like that covers this slide. If you haven't done an FN int in a while, you might want to. We could cover that if you
Just
need.
the calculator, right?
Yes,
Let's
I
just do-
don't really know how the instructor's been asking those in class. I mean, if you know how to do it, you always get the right answer.
It's just the like the math. Wait, math.
Math
9.
9. Like the type of problem I could see your instructor asking would be like the integral from 0 to 10. So let's go 0 to 4. Oops. 4. Square root 9 minus x squared, but then throw in an absolute value in here. Because this thing bounces at, I'm sorry, not square root, just 9 minus x squared. So this thing, it goes 9 to 3, but then there's an area underneath.
Okay.
So if you just do your FN int, you'll get positive and negative. But if you know to break this up into two integrals, one from 0 to 3, 9 minus x squared dx, and then minus integral 3 to 4, 9 minus x squared dx, that's how you get the right answer. Because
So should you graph it first, like on? Can you graph like on y equals, do like
yeah,
math number and then
you
put it in?
can. You can. Sometimes it's so close that you don't see it. It could also be on both sides. That's why I don't know. Do you know what kind of questions were these math 9 questions from class?
I don't really remember.
Okay.
Well,
Because it could also be something that's just written to see if you know how to enter it into your calculator.
but how do you know, like when I put it in the y equals with the, like, are you supposed to put it with the absolute value? Because
No. So
so
you
how
would,
do-
well, you could, but then it'll bounce. So if you
Yeah.
graph it with the absolute value, it'll go up like that.
But then I can't see the, if I just put 9 minus x squared, I don't see the, like the part under the x-axis really.
Yeah. So do you want to?
Like I just can't, how do I know to go to like 3?
So
And
3 is where it hits. And that's where you set 9 minus x squared equal to 0. And you solve it. You solve for x. But if you graph it, you should see it hitting there. Sorry, go ahead.
But like I don't know how to like graph it, just like from seeing the equation though is what I'm saying. Like
y1 equals 9 minus x squared. Like if you graph
but if
that,
you just, yeah, but then what about the bottom part? How do you do the bottom part?
You mean graphing this down here on the right?
Yeah.
You just have to change your window. I mean, it'll keep going. Let me pull up the calculator. I guess we're not speaking the same language here. So let me try something different. Let me get this.
Like what I see when I put 9 minus x squared in is just like a upside down parabola, basically.
Right. So let me share this, and this is the old style, so it's not gonna look as nice as that, but it's 9 minus x squared. And like you said, when you go to graph it, you get that, right?
Yeah.
So one thing you could do is you could change your window. You could just go from 0 to 4.
Okay.
Like that. And that way, when you graph it, you'll see the part that's above and below.
Yeah. Oh, I see. That's what, okay.
That's probably what I would do. I would graph the window. Now, I think your calculator has a absolute value. Let me see if I can get.
Yeah, it's like math number 1.
There we go. So I mean, you can do it this way too, and then it kind of takes care of itself, but you have to know to use fn int with the absolute value. Again, I'm just guessing here. I don't know what your instructor might come up with. The instructor could just as well give you a like here's another example I've seen. The instructor gives you some polynomial function of x, but it will be like x cubed minus something plus something plus, something like that, and it's got these zeros, and the instructor will like make you find the zeros and then find the areas between each of them.
Wait, can you switch back to the?
Oh, I'm sorry, I messed that up. Yeah, I forgot. So your instructor could give you a polynomial function of x, like x cubed minus 4x squared plus 2x minus 7. Who knows, right? Something like that. And it happens to have like these zeros.
Mhm.
Well, you might have to find them and then integrate. Like, let's say this zero is at 6.27 and this one's at 9.83 and this one's at 11.45. You'd have to use fn int with this function each time, from 0 to 6.27, 6.27, 9.83, 9.83 to 11.45.
For the one before, like when you put y equals, so if you do like y equals and then you do the absolute value of 9 minus, but doesn't that put it all above the x-axis?
Yes, and that's how you could use fn int. You just want to make sure you get the absolute value in there, and it'll take care of it.
But how do you get the like, would you still have to split it up then?
No. If you use absolute value, you can always just use the limits.
Okay. So
if you don't use the absolute value, you got to split it up.
Okay. So it is this 21.33, whatever.
Yes, and you want to convert that to a fraction and things like that. Another thing your instructor could do is put like a pi somewhere, and you would just leave that off until the end because it'll mess up your fn int calculation.
Okay. All right.
Okay, so the next slide here says rules for definite integrals. Let me snip that in. And I really don't know what that's referring to, but I think it's things like the integral from a to a, f of t dt is 0. That's one. Another one was like the integral a to b, f of t dt equals b to a negative f of t dt.
Yeah.
And then another one was something like if a to b f of t dt plus integral b to c f of t dt equals integral a to c f of t dt. And I think another one was like something like you could bring constants out. So if you have constant times f of t dt from a to b, that's the constant times f of t dt.
Yeah, I think I remember that one too. Yeah.
Okay. Basically all the sort of normal things that you would know to do seem to work here.
Okay.
I'm not sure what kind of example to apply here, but it's like those ones where they give you 3, they say integral from 0 to 4 f of t dt equals -3, comma, integral 4 to 6 f of t dt equals 8, and then integral 0 to 6 g of t dt equals, let's just make this weird. We'll make it pi.
Okay.
So that's given. And then they would ask you something like, what is the integral from 0 to 6 f of t dt?
So then that's the -3 plus 8, so 5.
Very good. Okay. So then they could also ask, like, what is the integral from 0 to 6 to f of t dt minus 3 g of t. Actually, let me put that dt on the outside. dt like that.
Oh, okay, so it's 10 minus 3 pi.
Yeah. Which is just 10 minus 3 pi. Now we saw a few of these the other day, so let me grab this again and just snip it down. So another possible scenario is that they could ask you, what is the integral from 0 to 4 f of t plus 5 dt?
Okay, so that's negative. Isn't it just negative 3 plus 5 again?
It's this first part's negative 3, but what's the antiderivative
Oh,
of
you have to
5?
do 0. No. 5x.
Yeah, 5t from 0 to 4.
Wait, why do you have to do?
You could also
Why do you
just
have to do
graph it.
that?
Well, because it's so you're separating that the real reason is because this is the integral 0 to 4 f of t dt plus integral 0 to 4
I see.
5 dt. And so if you want to graph it and say, okay, that's 5, that's 0 to 4, I'm finding the area there, or you can use antiderivatives, which is the same
So
thing.
it's just 20, negative 3 plus 20, so 17.
Right. Let's do another one. All right, so what is the integral from 0 to 6 g of t plus t dt?
Plus t. So the first part is pi,
That's right.
and then is it like t x at
The variable's t,
6?
so it's just assume it's an x here. What would it be if it was x?
What do you mean if what it was x?
You would write x squared over 2.
Oh,
for the
t
answer,
squared over
but it's just
2.
t squared over 2. Yeah.
I see. At 6, 0. So then that's 6 squared, which is 36 over 2, which is 18. So pi plus 18, yes.
I would look at these. This one, the last time I remember when I threw this like constant in, I think there was also like you said 5 again, but just maybe look at these examples again.
Okay.
To make this clear. So now let's use the same ones, and we'll do the mean value theorem because that's my next here. So the mean value theorem is 1 over b minus a integral from a to b f of t dt, or whatever it is. Like it could be g, doesn't really matter, but you take the endpoints. So the way this could work is it would say, what is the average value from 0 to 6 f of t dt?
Okay, so which one are you using though?
Well,
Oh.
so you just start writing out, okay, it's 6 minus 0, 0 to 6 f of t dt, and then you like hope you have some of these.
So 0, I don't remember what the.
Yeah, so 0 to 4 was minus 3, 4 to 6 was 8. So those together
You
make
have to do that, yeah, the 5. So
5.
that's 5. 1 over 6 times 5, whatever.
Yep.
So 5,
6. 5, 6, right? But I could make this again slightly more complicated, and say, give you this and say kind of the same question. Say, what is the average value of g of t plus 2 from 0 to 6.
Okay, so then it's 0 to 6 g t plus 2. So 1/6, and then that one is g of t. So that part is the pi, and then you have to do 2x at 6 and 0.
Okay.
So 12 minus 0. So 1/6 pi plus 12.
Right. Got it.
Do you like multiply the 1/6 and the 12, or?
I mean, now you're down to just preferences. Like this is also the same. Just as good.
But like, would you do like pi over 6 plus 2?
Good, but it's not necessary.
Okay,
These are all kind of the same at this point.
gotcha. Okay.
And again, like the instructor they could do so many things here. Like they could give you a curve. And they go A, B, C, D, and they could tell you that this is this area is 4, and this is 6 pi, and this is 3, and they could say they could tell you that A is -5, and D is 10, and they could say what is the average value, and we'll say f of x from A to D. It's 1 over D minus A this time.
10 minus or 10 plus 5.
Right.
Yeah, so
Integral from A to D, f of x dx.
15th. And then this is A to D, f of x dx. So do you just add them all up, like 4?
Well, but this area is negative if you're, because it's below the x-axis.
Oh, okay. So you do -4.
-4 plus 6 pi minus 3.
So then that's -7 plus 6 pi times 1/15.
Yes. It's like up to you if you want to simplify.
Okay. So those are all definite integrals.
Yes.
Okay.
You're only doing definite integrals right now.
Okay.
We'll just kind of preview. There are indefinite integrals. We're just going to preview kind of what's coming up. So part 1 and part 2, these are of the fundamental theorem of calculus. We've already covered these.
Yeah.
We've kind of already done this today, finding total area under a curve. Analyzing antiderivative graphically is like you make a graph and maybe you find it that way. I guess I'm not really sure what's meant there. So that's the next slide. The next slide after this is trapezoidal rule.
Yeah.
So, and that's, again, it's because it's on the AP, like it's heavily emphasized in the AP. It is not heavily emphasized in calculus classes around the country, and the AP it is. So that's the trap rule. There's a small variation, it's delta x over 2, and then use the leftmost endpoint and then 2 times everything in the middle.
And then the rightmost.
Yeah, and then just one value of that. So we'll do it again for a function and a tabular data. And then you've already done your review assignment. If there's any, we haven't really done any free response type questions, so you might want to have us look through some of those next time as well.
All right.
But I think that does it for today. So I'll see you tomorrow at our scheduled time, and I'll send you the notes here shortly.
Okay. Thank you.
Have a great night. Bye now.
You too. Bye.